Hey, welcome back, fellow scientists. So, quick overview of the school year, 4 weeks left. This week is all about the endocrine system. Next week is reproductive anatomy. The week after that is reproductive physiology. The week after that, we're going to talk about pregnancy and childbirth and different ways to manage or to use fertility, right? That's kind of the main reason why I, as a Christian school teacher, choose to do this unit on the endocrine and the reproductive system, right? As you guys mature and as you guys go into adult life, most of you will probably become married. And then as a married couple, you and your spouse need to determine, okay, are we going to manage our fertility? Some people don't, and they have like 12 kids. Some people don't, and they have 0 kids, right? Fertility is not something that God has blessed everyone with. In his special plan, he gives each of us our own unique gifts and abilities, and he makes each of us special. But fertility management is something that most couples should be aware of and should kind of know the basics of and know how to deal with. So as you proceed in your Christian life, that is something that is very, very important, because some ways of managing fertility are God honoring, and some ways of managing fertility are not God honoring. So we're going to talk about that probably in the very end of May, not quite into June yet. And then our last week of school is actually June 1st, 2nd, and 3rd. And the school just came out, I think, last week and said that the last day of school is going to be June 3rd. So we'll have a test one of those 3 days sometime in there, and then that'll be it. For you seniors, that'll be it for your high school science career. For you juniors, I can't wait to see all of you in AP biology next year. But anyways, we'll save that for later. So that's kind of an overview of the rest of the school year. What we're going to do for the endocrine system, we are going to have substantially more quizzes, excuse me, this week than we have, just because this week is all about glands and hormones and the effects that the hormones have. And so the more times that you write something down or that you type something in, the better or the more likely it is to stick into your memory. So there will be a quiz, one quiz a day. Might be multiple choice, might be fill in the blank. I might give you the gland and you give me the hormone and the action. I might give you the hormone and you give me the gland and the action, or I might give you the action and you give me the hormone and the gland. So yeah, we'll figure that out when we get there. As always, the quizzes will be on OneNote, or sorry, not OneNote, Microsoft Forms, and they will be open note, open book. Right, like I said, this is just kind of the teacher in me, like I can't just talk about something and then just let it go, but I need to get a response back from you. And so that quiz is going to be kind of that response back from you. So that's what this week is going to look like. We got a lot of stuff to cover. We're going to do half the hormones today and half the hormones tomorrow. And then Thursday for you guys, we're going to talk about feedback loops and how hormones kind of make a signaling cascade. And so that'll be interesting. So we're going to dive right in. As always, take notes on your own. I'll put the blank copy up on OneNote, and you guys are responsible. I'm not going to actually post my writing and my notes. You guys are responsible to write it down, and then you can use those for the quiz. So first and foremost, we're going to talk about the pineal gland. Pineal gland, we're only going to talk about one hormone, which is melatonin. Not a lot is known about it. It's not very active in humans. In other animals, it regulates circadian rhythms, and in animals that change their coat color during the seasons, right? Longer night or longer darkness increases melatonin. So in the winter, nights are long, melatonin is increased, and that has the effect of changing the rabbit's coat to white. And then spring and summer, the nights get shorter and the days get longer, so the melatonin decreases, and then that changes the coat back to a brown coat color. So pineal gland, melatonin, regulates circadian rhythms, or responds to length of day. That's kind of what we would say there. All right, next up, we're going to talk about the hypothalamus. You guys remember the hypothalamus is kind of right here, just above the pituitary gland. These hormones are really easy to remember because the ones that we're going to go over, right? Actually, sorry, let me back up. The hypothalamus is known as the master control gland. It's the main link between the nervous system and the endocrine system. It makes 16 hormones, and 7 are actually secreted. So made in the hypothalamus, but then actually secreted by the posterior pituitary. Right? That's just kind of useful information. We're not going to actually dive that deep into it, and we're not going to go over all 16 hormones. All the hormones that we do go over, they're all called releasing hormones because they're made by the hypothalamus, and then they travel through the bloodstream to the anterior pituitary. And those hormones, those cells in the anterior pituitary, they have the right receptors to respond to that hormone, and that hormone is going to make the cells in the anterior pituitary make their own hormones. So all the hormones that we're going to talk about for the hypothalamus are known as releasing hormones, and they just make the anterior pituitary release their other hormones. And the names are really descriptive, so it really works out well. Right? So growth hormone releasing hormone, its abbreviation is GHRH, which you can use on a quiz. It's totally fine. It makes or it stimulates the anterior pituitary, remember the front part of the pituitary, to release growth hormone, right? Which is abbreviated GH. If some people take human growth hormone as a supplement or as a medication for whatever reason, and so that's abbreviated HGH just to signify that it's from a human, or that from a human and acts on a human. So growth hormone releasing hormone is hormone number 1 from the hypothalamus. Thyrotropin releasing hormone, TRH, it makes the anterior pituitary release thyrotropin, right? Gonadotropin releasing hormone, it makes the anterior pituitary release gonadotropin. Prolactin releasing hormone, it makes the anterior pituitary release prolactin. And the corticotropin releasing hormone, it makes the anterior pituitary release corticotropin. Mr. Leo, what in the world do gonadotropin, prolactin, corticotropin do? We'll talk about that when we get to the anterior pituitary later on in the video, right? Right now, all you need to know is that the hypothalamus makes these hormones, gonadotropin releasing hormone, which travel through the bloodstream, right, to go to the anterior pituitary. Anterior pituitary has those receptors, and that hormone makes the anterior pituitary, those cells, release these gonadotropin, prolactin, corticotropin, right? All of these, thyrotropin, growth hormone, makes it release their actual hormones. So hypothalamus, master control gland, controls a bunch of other different things. Names are fairly self-explanatory and descriptive, so that's good. Praise the Lord for that, right? All right, next up, we're going to go to the posterior pituitary because there's only 2 hormones. Thank you, brain fart. 2 hormones that are released by the posterior pituitary. So, first of all, number 1, the posterior pituitary releases oxytocin. Now, as you'll note here, oxytocin is made by the hypothalamus, but then it's released right here by the posterior pituitary, and its main targets are the mammary glands and the uterus. Right. So let's go ahead and let's talk about just really quickly mammary glands. So mammary glands are actually glands inside the breast tissue. So here we have kind of 3 different layers of breast anatomy. So we have mammary glands right here, and then the mammary glands are encased in a covering of fat, right? And then the covering of fat and nerves are encased in epidermis skin tissue, right? So the oxytocin, right, that's going to travel through the bloodstream, and those glands, the mammary glands, are going to have those right receptors to respond to that hormone. And the main thing that oxytocin does is it stimulates letdown, or that's like an actual technical term. You can think of it as milk excretion. So mammary glands are just basically like modified sweat glands, right? So they make milk, which is controlled by a different hormone that we're going to talk about in a second. And so then the milk is kind of captured in those mammary glands. Those mammary glands can actually expand. And then once the time is right, when the baby cries, right, or the mom senses that the baby needs to be fed, then oxytocin will actually let the milk be released from the mammary glands, and then nourish the child. And then with the uterus, right? So here again, we're going to go over reproductive anatomy next week, but vagina, uterus, ovaries, fallopian tubes, right? So the uterus is like a big, gigantic muscle, right? So this is the womb. This is where implantation takes place. This is where the baby grows inside the uterus, and then this is what contracts during childbirth to help the baby be born, to push the baby through the birth canal and then out into the real world. So oxytocin, right? Main targets are mammary glands, where it stimulates letdown, and the uterus, where it stimulates contractions for childbirth. And that's one of your positive feedback loops that you guys probably did, right? So baby's head pushes on cervix, right? That sends a signal up to the posterior pituitary to release oxytocin. Oxytocin is released, uterus contracts, baby's head pushes on cervix more, and so it's a positive feedback loop that just keeps on getting more and more amplified until the baby is born. All right, now the thing that's really cool about oxytocin is that it's thought to promote pair bonding. So this is really cool, like with breastfeeding, right? Because oxytocin stimulates letdown so that the child can eat, right? But then it also creates in the mom this oh, I don't know, attraction, desire, protection, this strong feelings of attachment to like this child is hers, and she needs to take care of it, and at any cost. Like it's that whole mama bear, right? Like if you're hiking in the woods and you come across a bear on one side of the path and the cubs are on the other side of the path, like there's no way that it is advisable for you to be anywhere near there, because that's the mama bear, and she's going to protect her cubs, and she's gonna like that's oxytocin, right? Now, it also works in males to a lesser extent, but it also works in males during orgasm. It works in females with orgasm too, but with sexual partners. And this is where I love teaching at a Christian school, because I can address this content from a biblical perspective. So let me kind of explain it this way, right? We see God's design. We see his what he says in the Bible. We see it played out in biology, right? So let me put it this way, right? God's design in biology, any kind of sexual activity, okay, the end goal is orgasm or climax, right? Those are synonyms. For males, this means ejaculation of semen. For females, this means contraction of the vagina and tenting of the uterus to actually get into position to accept the seed or the sperm or the semen that's in the vagina. For both genders, what they feel during climax or orgasm is a feeling of bliss and well-being. And this, right, is when oxytocin is released in both genders, right? So and this, like we said, this creates pair bonding between mom and baby, but then it can also create pair bonding between sexual partners. So anytime that there's orgasm or climax, then you are actually chemically bonded to the person that you're with, or to something that you're thinking about, right? So God's best design for us and for our life and for our sexuality is one man, one woman for life. Physical intimacy actually produces chemical bonds, right? Like you hear that term, like, oh, there's chemistry between those two. Well, that's probably not true, but like it is true. There is like literal chemistry between people that promotes pair bonding, and that's why it's so important to know how serious this is, and to take God's word seriously, even if we don't understand it. Like to the nth degree, even if we don't understand it 100%, we need to know that God is in charge, and that God has the best plan for our life, and we would do well to follow His plan. Now, it's a sinful world, right? There's death that can cause people to get remarried. There's divorce because of sin that can cause people to get remarried. But as far as it concerns us, we should always try to do our best to follow God's plan for our lives, which is one man. Marriage is one man, one woman for life. So that's a rabbit trail. I apologize, but like I said, this is one of the benefits of being at a Christian school, because we get to address these topics and talk about these topics in a God honoring way. And this is one of the benefits for me teaching at a Christian school, because I get to bring that up, and I get to couch it or to present it in biblical terms. So hopefully that's helpful. If that wasn't helpful, I apologize. So all you really need to know for oxytocin, posterior pituitary, is it stimulates letdown and it makes the uterus contract during childbirth. All right, so that's one hormone for the posterior pituitary. Second hormone for the posterior pituitary is called antidiuretic hormone, or ADH. This also is actually made in the hypothalamus and it's released by the posterior pituitary. Its target is the kidneys, and it decreases urine output, so it increases the water in the blood. So if you're dehydrated, your posterior pituitary is going to release antidiuretic hormone, and that's going to cause your kidneys to retain more water so that you have more water in your bloodstream. All right, so those are the two hormones for the posterior pituitary. And then we have one more gland that we're going to talk about. I think we have like five different hormones for this gland, but hang in there. We're almost through. So anterior pituitary, controlled by hormones from the hypothalamus. So all those releasing hormones that we talked about, right, made in the hypothalamus, travels down the bloodstream into the anterior pituitary, right? You can kind of see here, posterior pituitary, right, mainly controlled by nerves, right, a little bit by blood, but mainly by nerves. Anterior pituitary mainly controlled by blood. So there's hormones that are made in the hypothalamus that are released in the anterior pituitary that make it release its hormones. So here we go. Hormone number one, human growth hormone. We talked about this. Main target is the liver, causes the liver to release more glucose. Glucose equals energy. Thank you, cellular respiration. More energy equals more growth. Prolactin is a hormone that is released by the anterior pituitary. Again, its target are the mammary glands, which we talked about already. Here's a different diagram. Maybe gives you a little different picture. So this is what's responsible for milk production. And then there may be questions. There is no known function for prolactin in males. So then third hormone, thyroid stimulating hormone, TSH. So its main target is the thyroid, and it makes the thyroid secrete its hormones, right? So with this, we have like a three-step cascade so far. So the hypothalamus makes the thyrotropin releasing hormone, which goes down to the anterior pituitary, which makes the thyroid stimulating hormone, which then goes down to the thyroid and makes the thyroid make its hormones, and then those hormones go and they actually have an effect. So kind of convoluted, but we'll see on Friday how that actually works and why that's a good thing. Next hormone that's made by the anterior pituitary is the adrenocorticotropic hormone, or ACH. So its main target is the adrenal cortex. Remember, that's the outside of the adrenal glands. Adrenal medulla is kind of the inside of the adrenal glands. So it makes the cortex secrete cortisol, which again we're gonna talk about. So that's another like three-step cascade. And then here we go. So follicle stimulating hormone. So these are gonadotropins, follicle stimulating hormone and luteinizing hormones, because their targets are the gonads, right? So follicle stimulating hormone, we'll take that one first. Main target is the ovaries and testes. It stimulates production of ova, right? So here is an ovary and here is a fallopian tube. So ovaries are where the ova are, stored and matured and produced. And then it also helps regulate the monthly cycle. So over here, right, we can see we have our follicle stimulating hormone, which during the menstrual cycle or the monthly cycle, rising and falling levels of hormones kind of help with that or dictate that, right? So that's what it looks like in females. In males, right, sperm is made in the testes. And then it travels along a whole path, which we'll talk about when we get to reproductive physiology. But the follicle stimulating hormone helps that whole process to proceed, right? And then next up, we have luteinizing hormone. Again, main target is the gonads. In males, it stimulates the production of testosterone. Testosterone is technically classified as a lipid, right? And we can see it right here. It's a lipid. It's a steroid hormone. It's very hydrophobic, right? Notice testosterone and estrogen. I love this, right? Because look how similar they are, right? Look, like count the number of differences. There's only like 3 differences that I can tell, right? Here, there's a methyl group. This is a CH3 with testosterone. And then there's no double bonds over here, and there's no H over here, right? Estrogen, there's an H here, there's double bonds here, and then there's no methyl group there, right? Like that is really, really similar, and yet they have two like drastically different effects. So I'm just constantly amazed at how intricate and how wonderful the human body is. And then in females, luteinizing hormone also stimulates the production of estrogen. So if we go back over here to our little chart, right, and we'll talk about the menstrual cycle or the monthly cycle later on when we get to reproductive physiology. So we'll talk about this later. But we have follicle stimulating hormone, luteinizing hormone, estrogen, right, also kind of plays a role, in progesterone, which we'll talk about in a little bit. Not on this video, but as we get further along, probably on Tuesday, we'll talk about that. So anyways, so that's follicle stimulating hormone and luteinizing hormone. And I think that is the end. Yeah, because then we're into the thyroid. So that's where we will start on Tuesday. So this has been Mr. Leo. Hopefully this has been educational and informative, and I will see you on the flip side.